Now we are going to discuss about allocation methods. The direct access nature of the disk gives us flexibility in the implementation of files. So in almost every case, many files are stored on the same disk. The main problem is how to allocate space to these files so that the disk space is utilized effectively and the files can be accessed quickly. There are three methods that are used for allocating disk space. First one is contiguous allocation, then we have linked, and then we have indexed. All these methods have their own advantages and disadvantages. Now we are going to discuss about contiguous allocation. Contiguous allocation requires that each file occupy a set of contiguous blocks on the disk. Disk addresses define a linear ordering on the disk. With this ordering, assuming that only one job is accessing the disk, accessing block B plus 1 after block B normally requires no head movement. When head movement is needed, the head needs only move from one track to the next one. Thus, the number of disk seeks required for accessing contiguously allocated files is minimal, as is seek time when a seek is finally needed. Accessing a file that has been allocated contiguously is easy. For sequential access, the file system remembers the disk address of the last block referenced and when necessary reads the next block. Contiguous allocation has many problems. First, difficulties finding a space for new files, and it suffers from external fragmentation. As files are allocated and deleted, the free disk space is broken into little pieces. External fragmentation exists when free space is broken into chunks. It becomes a problem when the largest contiguous chunk is insufficient for a request. Storage is fragmented into a number of holes, none of which is enough available to store the data. Depending on the total amount of the disk storage and the average file size, external fragmentation may be minor or it can be a major problem. One strategy for preventing loss of significant amount of disk space to external fragmentation is to copy an entire file onto another disk. The original file is then freed completely, creating one large contiguous free space. We then copy the files back onto the original disk by allocating contiguous space from this one large hole. This scheme effectively compacts all free spaces into one contiguous space, solving the fragmentation problem. Another problem with contiguous allocation is determining how much space is needed for a file. If we allocate too little space to a file, we may find that file cannot be extended. Even if the total amount of space needed for the file is known in advance, pre-allocation may be insufficient. A file that will grow slowly over a long period must be allocated enough space for its final size, even though much of that space will be unused for a long time. The file therefore has a large amount of internal fragmentation. Now, to minimize these drawbacks, some operating systems use some modified version of the contiguous allocation scheme. Here, a contiguous chunk of a space is allocated initially. If that amount proves not to be large enough, another chunk of contiguous space known as extend is added. The location of the files block is then recorded as a location and a block count plus a link to the first block of the next extend. On some systems, the owner of the file can set the extend size, but this setting results in inefficiencies if the owner is incorrect. Internal fragmentation can still be a problem if the extends are too large, and the external fragmentation can become a problem as extends of varying sizes allocated and deallocated. Now, in the next video, we'll be discussing about linked allocation.